Chemistry. Zinc was added to aqueous copper 2 sulfate solution. Part A. Describe what could be observed in the above reaction. So how do we answer such a question? So you need to understand that zinc is reacting with copper 2 sulfate. So this type of a reaction, it is called displacement reaction. So in this reaction, it will take place because zinc is more reactive than copper. So copper will be displaced by zinc. Okay, so now the question is demanding on the physical appearance. So you need to understand that copper 2 sulfate solution, it is blue in color. So when we put in zinc, the color, it will not remain the same as blue. So what is going to happen is that the blue color of copper 2 sulfate solution will change to colorless, which is zinc sulfate solution. So the blue color of copper 2 sulfate solution, colorless, zinc sulfate. Solution. Part B, 13 grams of zinc completely reacted with aqueous copper 2 sulfate solution. Part 1, construct a chemical equation for this reaction. So a reaction of zinc and copper 2 sulfate. So we have zinc plus copper 2 sulfate. So this is a displacement reaction. What we are going to have is zinc sulfate plus copper. Then the last part is calculate the mass of copper produced. So we have 13 grams of zinc. 13 grams of zinc. What we are looking for, it is the mass of copper. So we have zinc, then we have copper. So in this case, we have 13 grams of zinc. What we are looking for, it is the mass of copper. Then molar mass of zinc, the molar mass of zinc is 65. That is on the periodic table. Then the molar mass of copper, it is 64. So from here, I'll cross multiply. So what do we have? So what we have is 65 equal to 13 times 64. So over 65. So 65 goes. X is equal to, what we have is 12.8 grams. So the second question is, the grid below represents part of the periodic table. The numbers shown represent the atomic numbers of elements. So these are the atomic numbers of elements. Then from the grid above, select the atomic number of an element which is a noble gas used to fill balloons. To answer this question, you need to make a reference to periodic table. So now the element that is used to fill balloons, it is helium. So when you check on this periodic table, helium, it is used to fill in balloons. Its atomic number is 2. So the atomic number of an element, which is a noble gas used to fill balloons, so there it is 2. So from the grid above, select the atomic number of an element which is the most reactive metal. So the most reactive metals, they come from group 1. So group 1 are the most reactive metals. But among group 1 metals, there are those that are most reactive than others. So now, how do you know that this element is more reactive than other in terms of metals? So these metals, as you go down the group, the reactivity increases. So that simply means that this element is more reactive than this one. So 11, which is this one, it is more reactive than these elements. So the most reactive in this group, it is 11. So here the most reactive metal is 11. Then the most reactive non-metal. So the most reactive non-metals. So now what you need to understand is for the non-metals, the most reactive non-metals, these are group 7 elements. So group 7 elements are the most reactive non-metals. So for group 7 elements, we've got these two. So for non-metals, as you go up the group, the reactivity increases. So meaning this element is more reactive than this one. So the most reactive is 9. Then D forms an ion of the type, so meaning this ion, it is negatively charged. This simply means that this is a non-metal. It's a non-metal because non-metals, they carry a negative charge. Then number 2, this simply means that it is gaining 2 electrons. Okay, it is gaining 2 electrons. So those that gain 2 electrons, those are group 6 elements, which are non-metals. They will gain 2 electrons. So in here we have these two. So I'll go for oxygen, which has the atomic number of 8. Forms an amphoteric oxide. Forms an amphoteric oxide. So there are those that we call amphoteric metals. Amphoteric metals such as zinc, lead, not forgetting aluminium. So in this case, we have aluminium. So aluminium, it has the atomic number of 13. So it has an atomic number of 13. So it will form an amphoteric oxide. Why? Because it is an amphoteric metal. So 13. Then the last one forms a hydroxide that dissolves in water. So an hydroxide that dissolves in water. So when you check group 1 elements, we said that they are the most reactive metals. So those metals, they are called alkali metals. Why are they called alkali metals? They are called alkali metals because they form an alkaline solution whenever they react with what? With water. Okay, so which is an hydroxide. So that hydroxide, it dissolves completely in water because group 1 elements, they form strong bases, which is alkaline. So it forms an hydroxide that dissolves in water. They are group 1 elements. So we have 11.